Hi everybody. So just now I'm going to brief you about AMS Amsterdam Modelling Suite and the different applications of the software for various calculations. So speaking about Amsterdam Modelling Suite, we must focus on the following modules from ADF to ReactFF for computational engines. Speaking about ADF, ADF is known as Amsterdam Density Function, especially for molecular DFT calculations where we can use it for electronic structure property predictions or calculations, transition state search, including the spectral studies and energy decomposition analysis or other bonding analysis. And then followed by ADF, it is band module. Band is exactly used for DFT calculations, but not for molecular systems, but for periodic systems, where we can calculate the density of state, phonon dispersion calculations, including for solid states and large systems. We do have a GUI for WASP. I will show you the WASP GUI, which can be helpful for preparing the inputs. For example, if you don't have a GUI for WASP, you have only a source code, you can prepare the input and run the calculation and doing the analysis within our platform, including the post-processing analysis. Then we have the DFTB MAPAC package, density fitting type binding, which is useful for electronic structure properties, especially for larger systems, but the accuracy lies in between DFT and Hartree-Fock theories. So it is mainly used for large systems, including the heater formation predictions. Then we have the Cosmo RS module, which can be useful for various solubility predictions, and mainly it is useful for statistical thermodynamics as well as solvation chemistry calculations, and could be used for pharma for predicting the solubility of mixtures, vapor pressure, and other thermodynamic properties for binary systems and mixtures. Hopefully this is the GUI for AMS Cosmo RS. And then speaking about the other module or application, which is known as ML potential. So this module will be helpful for it is known as machine learning potential, which can be helpful for designing new models, which is actually not a physics-based model, but it is a machine learning training model where we can able to predict the properties of various molecules. For example, if a user want to predict something quick or want to predict a quantitative structure property modeling, we can use ML potentials to predict the properties of 1,000+ molecules, which will be time consuming in DFTV, ADF, or band-based module. So ML method is an alternative. So if you or if the user want to have an approximation of these properties, we can filter them, or you can just focus on the best ones and do the physics-based methods. And the next most important module is the reactive force field module, or ReactFF. So it is a set of force fields which can be used for molecular dynamics, Monte Carlo simulations, and even QMMM methods, where we can train new force fields, or else we can generate or model new force fields. Then we have the capability for using a module called params or parametric AMS, where we can train new force fields, which is a part of an advanced workflow package. But it should require either DFTB or ADF or ReactFF module to generate new force fields. So then we have an interface known as PLAMS. So this is the interface of parametric AMS. So then we have an interface known as PLAMS. PLAMS is a Python interface for our package, so which will be very useful for post-processing analysis. So you can see how to create the PLAM script after generating the inputs. You can export the PLAM script. So PLAMS, speaking about PLAMS, it is very useful for post-processing, or if you want to integrate any open source tools using Python package libraries, we can use this Python interface either through terminal or even through Jupyter Notebook. So we have another module which is known as the AMS driver or AMS driver, which will be a little bit advanced. If the users want to integrate any other open source packages like LAMS or any open sources, we can integrate it through AMS driver. So it is just like an integration of external tools of AMS softwares. So this is actually an overview about AMS. Thank you. Hi everybody. So just now I'm going to brief you about AMS Amsterdam Modelling Suite and the different applications.